Most people think of the northern lights as something they see, a beautiful sky, a photograph, a bucket list destination. But some people claim they have heard them. Years ago, while living in Inuvik, Northwest Territories, this author witnessed an unusually bright and active aurora display. The lights moved rapidly across the sky, folding and shifting above the Arctic landscape. And there was something else, a sound, not loud, not dramatic. It resembled distant radio static. For many years, reports like this were dismissed. The lights occur high above Earth, often more than 100 kilometers overhead. Sound from that altitude cannot reach an observer instantly. If people were hearing something at the same time they were watching the lights move, scientists reasoned that the sound must be coming from somewhere else, or perhaps not exist at all. Yet reports continued. Across northern Canada, Alaska, Scandinavia, Finland, and other polar regions, people described hearing faint crackling, hissing, whispering, or static-like sounds during particularly active auroral displays. To understand why this question remains fascinating, it helps to understand what the aurora actually is. The story begins on the sun. The sun continuously releases a stream of charged particles known as the solar wind. Most of these particles pass harmlessly through space, but some eventually encounter Earth. Fortunately, Earth possesses a magnetic field. This magnetic field acts like a protective shield, deflecting much of the incoming solar wind. Without it, the atmosphere would be exposed to far greater levels of energetic radiation. But the magnetic field does not simply block these particles, it guides them. Near the north and south poles, magnetic field lines converge and create pathways into the upper atmosphere. Charged particles become funneled toward these regions, where they collide with oxygen and nitrogen high above the planet. Those collisions release energy in the form of light. The result is the aurora. What we call the northern lights, or Aurora Borealis, is not a thing floating in the sky. It is the atmosphere itself glowing. The southern hemisphere experiences the same phenomenon. There, the displays are known as the Aurora Australis, or southern lights. Although they receive less public attention because fewer people live beneath them, the process is identical. Charged particles follow Earth's magnetic field toward the South Pole, where they collide with atmospheric gases and produce luminous displays across Antarctic skies and the southern oceans. The colors depend on which gases are involved and at what altitude the collisions occur. Green is the most common color because oxygen emits green light at typical auroral altitudes. Red auroras can occur higher in the atmosphere where oxygen behaves differently. Nitrogen contributes blue, purple, and pink tones, especially during energetic displays. The dancing curtains, rippling waves, and moving arcs are visible expressions of changing magnetic fields and streams of charged particles interacting with Earth's atmosphere. In a very real sense, auroras are visible space weather. Earth is not unique in experiencing this phenomenon. Auroras appear wherever charged particles, magnetic fields, and atmospheres interact. Jupiter possesses some of the most powerful auroras in the solar system. Its immense magnetic field captures enormous quantities of charged particles. Some originate from the solar wind, while others come from Jupiter's volcanic moon, Io. The resulting auroras can be hundreds of times more energetic than those seen on Earth. Saturn also displays auroral activity around its poles. Even Mars experiences auroras, despite lacking a strong global magnetic field. Localized magnetic regions within the Martian crust create smaller, patchier versions of the phenomenon. Uranus and Neptune possess auroras as well, though their unusual magnetic field geometries create patterns unlike those found on Earth. Wherever magnetic fields and charged particles meet, the universe seems capable of producing light, and perhaps, under the right conditions, sound. The possibility of auroral sound remained controversial for decades because of a simple physical problem. Auroras occur too high in the atmosphere for ordinary sound waves to arrive simultaneously with the visible display. If observers hear crackling, hissing, or static at the same moment they see the lights move, then the sound cannot be traveling directly from the aurora itself. Modern research has suggested a different possibility. During periods of strong auroral activity, disturbances in Earth's magnetic field may influence electrical conditions closer to the ground. Under certain atmospheric conditions, especially during cold temperature inversions, common in northern regions, electrical charges may accumulate near the surface. Geomagnetic disturbances associated with auroral activity could potentially trigger small electrical discharges within this charged layer. The sound people hear may therefore originate only a few meters above their heads, rather than 100 kilometers overhead. The aurora may not be producing sound directly. Instead, it may be triggering conditions that allow sound to be generated much closer to the observer. This remains an active area of investigation. Researchers have successfully recorded faint popping and crackling sounds during periods of strong auroral activity, but many questions remain unanswered. What makes the subject especially intriguing is the consistency of the reports. Long before radio technology existed, indigenous peoples across Arctic regions described sounds associated with the lights. Their descriptions often included whispers, crackling, rustling, or voices carried through the sky. Centuries later, modern observers began using a new comparison. Radiostatic, different cultures, different eras, different languages. Yet many descriptions point toward a similar experience. Whether every reported auroral sound represents the same phenomenon remains unknown. Perhaps that is part of what makes auroras so compelling. They exist at the boundary between worlds. They are atmospheric, yet driven by events occurring on the sun. They are local, yet connected to processes unfolding across millions of kilometers of space. They are familiar enough to photograph, yet strange enough that scientists continue studying them. And occasionally, on a cold Arctic night beneath a sky alive with motion, they may offer more than light alone. The atmosphere above us is constantly interacting with forces originating far beyond our planet. Most of the time, those interactions remain invisible. Auroras are among the few moments when space weather becomes visible to the human eye, and perhaps, under the right conditions, audible as well. The lights themselves may be beautiful, but the deeper story is that they reveal a connection between the sun and earth, between magnetism and atmosphere, between physics and experience, and perhaps most intriguingly, between observation and mystery. Because despite decades of scientific study, one question remains surprisingly difficult to answer with complete certainty. What exactly was that sound? For this author, standing beneath an active Arctic aurora in Inuvik, the answer was not a voice, a whisper, or anything supernatural. It sounded like distant radio static. Whether that sound originated from the aurora itself, from electrical activity closer to the ground, or from some interaction not yet fully understood, remains a subject of ongoing investigation. But the memory remains: a sky alive with motion, a landscape suspended in silence, and somewhere between Earth and space, a sound that may not have belonged entirely to either,